Hi, this is screencast number 3 for Unit 1, Lesson 3, and I'm on page 42. Look at the bold blue heading that says, what are some characteristics of good scientific investigations? Scientists may use different methods to test the same hypothesis, but good scientific investigations share some important characteristics. Scientific observations should be well documented and have supporting evidence. In an experiment, the variables should be controlled as much as possible. However, not all experiments require that you have a control. Remember, a control is basically the same as the experimental setup, except that it lacks the independent variable. Okay? Experiments should be repeated multiple times by the original investigator. Okay, scientific investigations should be able to be replicated, meaning repeated, by scientists not involved with the original work. This helps ensure objectivity, okay, so that somebody who's not involved originally can come along, do the same experiment or same investigation, and come up with the same or similar results. Okay. If the investigation is valid, the same results will be found. Okay, when scientists work on a scientific investigation, often what they do is they will publish their findings of their work in a scientific journal of some sort. Okay, but next paragraph. Before publication, the experiment undergoes peer review, meaning other scientists are going to look at it. Okay, so it's going to undergo peer review by scientists not involved in the original investigation. Okay. All right, go down to the next paragraph and find the sentence that says, processes of peer review and replication help to ensure that mistakes are identified and corrected. Okay. Let's see, go to page 43. How can you evaluate the quality of scientific information? Scientific information is available on the internet, on television, in magazines, etc. Some sources are more trustworthy than others. The most reliable scientific information is published in scientific journals. This would be the journal or the publication that a scientist would put his work in. For instance, the Journal of the American Medical Association, or a lot of your sciences have specific journals, the Journal of Soil Science or something like that. Okay, so the most reliable scientific information is published in scientific journals. People magazine is not a scientific journal. The Inquirer is not a scientific journal. Okay, you are not going to go to the grocery store and see scientific journals for sale primarily, okay? Because most of the people that subscribe to those publications are other scientists of the same variety, okay? All right. So the problem with those scientific journals is a lot of times those articles are very techy. The language is used for scientists, and these articles are often hard for the normal person to understand. Okay, so sometimes summaries of these articles are written in a way that's easier for non-scientists to understand. So for instance, you might find a summary of the findings maybe in a newspaper, written more for everyday folks. Okay, but please understand the most reliable scientific information is published in scientific journals. Okay, all right. Go to the next paragraph. Many scientists and non-scientists write books for the general public. These publications are trustworthy if the person is knowledgeable about the field of study, if they're considered an expert in that field. Okay, usually the most reliable internet sources are government or academic web pages. Government would be like cdc.gov, the Centers for Disease Control. That's a government website. Or academic web pages, something put on by a university, for instance. Okay. Commercial web pages are often unreliable because they are usually trying to sell something. Commercial web pages would be web pages of business that are in business to make money, okay? And obviously they're going to make money if they can sell you something, and so they may not be reliable sources of information, especially when it comes to things that they're trying to sell you. Commercial web pages are often biased. Remember that bias means favoring one result over another. Okay, bias is a slant that changes how information is presented. Okay, on number 16, you are free to omit that one. You may write omit across number 16. Let's go to number 15 and let's talk about a scientific investigation that Galileo did several hundred years ago. Okay, so look at the cartoon and it shows Galileo leaning out of the Leaning Tower of Pisa doing an experiment. And he had two balls of different masses, and he dropped them and noticed that they fell at the same rate, meaning that they hit the ground at the same time. Okay? All right, so look at number 15. When scientists replicate experiments, they will often do so under different conditions than the original investigation. Why might this be helpful? Why do you think that the astronauts replicated Galileo's investigation on the moon? Okay, they did actually in 1971. One of the astronauts simulated this same experiment and did it on the moon. Okay, so if they do it under different conditions and they get the same answer, then it tells the scientists whether the results are the same regardless of the conditions that the investigation is done in, or whether those conditions affect the results that you see. Okay, y'all know that if I drop a hammer and a feather here on Earth, the hammer is going to hit the ground first, and the feather is going to be slower to get to the ground. The reason for that is the fact that the feather is more subject to air resistance. Okay, but if we have two masses that are heavy enough, like Galileo dropping two lead balls from the Leaning Tower of Pisa, they're both massive enough and go through the air quick enough that they look like they hit at the same time. Okay, so what the astronauts did in 1971 is they repeated the experiment on the moon. Okay, and if you look at page 43, it says over 300 years later, scientists were still replicating Galileo's investigation. In 1971, astronaut David Scott traveled to the moon, which has no air. The moon has no atmosphere. When he dropped a hammer and a feather, they hit the ground at the same time. And the conclusion for that is that yes, things are pulled to the surface of a planet at the same rate with the same acceleration. The only thing that slows it down here on Earth is the fact that there's air resistance. Okay. What I would like for you to do before you turn this lesson in, there is a YouTube video on my website that shows this particular investigation. It shows the astronaut dropping the hammer and the feather on the moon. It is 1971 technology, so the footage is kind of grainy. But if you'll listen very carefully, he'll actually tell you what type of feather he is dropping. And if you can write that down on the very back page where your vocabulary is going to be, I will give you a couple of bonus points. All right. So let me show you what I've got now that we've had a chance to talk through this. Okay, so I went back and I highlighted on page 42, it says scientific observations should be well documented and have supporting evidence. In an experiment, the variables should be controlled as much as possible. Next paragraph, I highlighted the first sentence, which says experiments should be repeated multiple times by the original investigator. The last paragraph on that page, there is a sentence that says processes of peer review and replication help to ensure that mistakes are identified and corrected. I also have down here an answer to number 15, so if you're paying attention, you'll have that one answered. On page 43, I highlighted where it says the most reliable scientific information is published in scientific journals. Okay, however, these articles are often difficult to understand. Sometimes summaries of these articles are written in a way that's easier for non-scientists to understand. The next paragraph, usually the most reliable internet sources are government or academic web pages, meaning something that's run by the government or something that's run by a university. Commercial web pages are often unreliable because they are trying to sell you something. Commercial web pages are often biased, and remember that bias is a slant that changes how information is presented. They're going to try to present it in such a way that convinces you of what they want you to know. And last but not least, I'm on the very back page where you have room to write notes and vocabulary words. The vocabulary words that I expect you to define: experiment, observation, hypothesis, variable, independent variable, dependent variable, data, method. Method we've actually run into already, and remember that it's the way that you do something.